Azure. Hello, this is Nitesh Sharma, your host. Welcome to my course, Microsoft Azure Developer Implement IaaS Solutions. This module is about creating, managing, and running containers in Azure. And I have broken it into three major sections based on the requirements for the Azure 204 exam. We are going to start off by learning how to use Docker tools to create container images. We will look at what a container is, the process for building a container image for simple .NET Core applications, and then learn how to run that container locally on our local workstation. Next, we will take that container image and push that container image into Azure Container Registry. Azure Container Registry is managed container registry service based on the open source Docker Registry, allowing you to build, store, and manage container images for your container-based application deployments. Then we will take that container image and run it as container in Azure Container Instances. Azure Container Instance is an Azure service that allows us to run one or more containers in Azure with no server or infrastructure to manage. We are going to start off with some container fundamentals. Containerization of applications allows you to package up your programs, binary libraries, and other required components into a single deployable binary package called a container image. A running instance of a container image is called a container, and inside that container is your running application. And so your application up and running and able to consume the resources provided by the operating system. Generally speaking, you will run one application inside of a container as the container image become the deployment mechanism for your application. And so container image are generally going to be very small and portable. And the key what that container image become portable is via container registries, which allows for container image to be easily shared and used. Let's look at the comparison of virtual machines and containers. With virtual machine, for years you have been buying and deploying physical servers and installing hypervisors on top of that hardware. And we then created virtual machines and installed full operating systems on those virtual machines and then deployed our applications on top of each of those virtual machines. This model was great for increasing hardware utilization by increasing the density in which applications were deployed. But this model left us with maintenance tasks for each of these guest operating systems, and deployment times for VMs and apps was very slow and often manual. You still have a foundational compute component, and this can be either a physical or virtual machine. You then install an operating system on top of that. From there, you deploy a container runtime, which enables you to virtualize the OS, and then each container deployed has an isolated view of the underlying operating system. And from each other, the application running these containers through can communicate with each other over the network. Since the entire application is contained within that container image, this dramatically simplifies the application. Since the entire application is contained within that container image, this dramatically simplifies application deployments to just setting up your container from container image. In this module, we are going to focus on Azure Container Instances, which gives you underlying compute platform as service, so that you can deploy containers without having to worry about any infrastructure servers. or even the underlying host operating systems. You can focus solely on your applications, how they are built, configured, and deployed. Let's look at the build and deployment process for these containers now. So, with fundamentals behind us, the next thing that I want to introduce you to is process of building a container image. Storing a container image in a container registry and running a container image as container in Azure Container Instances. So it sounds a bit confusing. So this is the whole process. If I can just make it like this, nice design. It's like your Google specs. Container and so on development. And so on a development workstation, we will use locally installed Docker tools to build a container image. And to do that, we will write a Docker file. In the most basic form, a Docker file is a sequence of commands or instructions used to build a container image. Common instruction in the Docker file includes copying a compiled application binary into the container image and also defining which binary or scripts run when a container is started from a container image. Additionally, a Docker file is used to craft the environment inside the container for your application. So perhaps copying configuration files or even setting environment variables. We will look at the details of the Docker file in the moment. Once the Docker file is written, you execute the docker build command, and that will create a binary container image stored on that local workstation. Inside that container image would be application binaries and configuration needed to run that application inside a container. Understand, right? So you have binaries, libraries, you have image, and then to build, and you build it and you have it on your development workstation. And now you need to push it. So once it is done, once the Docker file is written, you execute the command build, right? And then that will create a binary container image. And then, as I said, the inside that container would be the application binaries and configuration needed to run that application inside that container. Essentially, anything defined inside a Docker file will be affected inside the container image. With that container image created, it can then be run locally as a container to test out our application. Once you have a functioning container image, you can then push the container image into a container registry, which is Azure Container Registry. Once the container image is pushed to really upload it to the container registry, it can then be shared with the other users or container orchestrator to pull that image down and run that image as container in that environment. In the course, in this course, we are going to work with Azure Container Instance, and you can create a running container in ACI using many of the standard deployment tools for Azure. So the Azure portal, Azure CLI, Azure PowerShell, and so on will be the mode of creation of Azure ACI, Azure Container Instance. And so once we request the container to start by specifying the container image that we want to run, the container image will be pulled down to ACI and started up. Once that container is up and running, user can start using our container based application. So once it is pushed to Azure Container Registry and then it is pulled by the Azure Container Instance, then our app is up and running. It can be usable. So as I promised, we have the Docker file, example of Docker file, and this is how it looks like. From mcr.microsoft.com.net core ASP.NET Core 3.1. So what we are saying here, I want to use the ASP.NET Core 3.1 from this location. Okay, and then what I want to do is I want to create a folder in my container, then copy the uh, the web app bin release from the publish folder to config.sh, and then run bash config.sh, expose it to 80, and the end entry point of .NET web app.dll, and that's it. Looks simply high level commands, right? We are saying pretty high level things we are doing. So time to dive into our Docker file. For our container based application here, we are going to package into container image a simple C# based hello world container web app. This example Docker file will show you how to build a container image for this. I will also show you some common instructions used to configure the environment inside the container image for an application. Most Docker files will start with a from instruction. This defines our base container image used for subsequent instructions in the Docker file. This is the foundation of which you are installing your application. Here we are using ASP.NET Core 3.1 image from the container registry mcr.microsoft.com. This is an official container image from Microsoft, providing the core things needed to run a .NET Core web application. Inside of the container, anything we do from here inside of our Docker file will be built onto this base image. We now want to configure the environment inside the container image to run our application. The next instruction that we'll use is the run instruction. The run instruction will execute a command inside the container for a command that exists inside the container. And so here you can see run mkdir /app. This will create a directory named /app inside container image. Now another common instruction that you may use when building container image is work directory. This sets the working directory for any subsequent instructions in the Docker file. Now with the environment laid out, we can use the copy instructions to copy our application binaries into the container. And so here I'm copying my compiled application from local directory on my development workstation into the container image. The binary are in the relative path ending in the publish, and they are being copied onto container image into the current working directory, which is /this dot is actually the app. This is actually the app directory which we set the working directory in the previous instruction. Now let's see, we needed to copy another file into the container, perhaps a script that needs to be run inside the container. Here I'm using copy instruction to copy config.sh into the directory, which is actually the app directory, since that's the current working directory. Now that the script is inside the container, we can execute the script with the run instruction. We define which cell we want to run the script in and then pass the script name as parameter. So here we see run bash config.sh. If this was another shell like jar shell or even PowerShell, I would specify the shell binary here and then the parameters needed to call the script that we want to launch. And of course, those binaries and scripts would need to be available inside the container, the expose container. The expose instructions tell the container's runtime which port the application running in the container is listening on, and in this case this is 80. And the final instruction is entry point. The entry point instruction is used to define which script or binary we want to start when the container is started from this container image. And so inside the square brackets we will define the command that we want to run and then its parameters. And so we are going to launch the .NET command with the parameter of our compiled application binary, which is webapp.dll. This DLL was copied into the container image during that first copy instruction that we executed. Also important to call out is that we don't have to specify the full path to the DLL since we set the working directory using the work directory instruction. In some application scenarios, the CMD or the command instructions is used to start the application in container image, and so you will see that sometimes entry instead of entry point with this Docker file return, we execute the docker build command with the parameters -d web app image slash v1, and so a name is human readable string to help us reference a container image by name. And so here we used web app image to help describe our application. The tag v1 is used to help version control our image over the time. As newer images are produced, we can increment this value to match new version of our application, and then we can differentiate between versions as well. Time to get into our demo. Let's create a container image for simple .NET Core web application together using Docker. So here we are with Visual Studio launched on our development workstation. Let's do a demo. Okay, time to get into our demo. Let's create
we have this demo
image for simple
and
Core
we
web
have some
application
prerequisites for
together
this demo.
using Docker. So here
Initially
we are
is
with Visual
actually
Studio
what you
launched
have
on
to do
our
is
development
what you want to do is we
workstation.
just want to publish
Let's do a
a
demo.
web app to the container registry. Okay, so to do that we need to install the Docker, we need to have a .NET Core SDK. If you already have these things, perfect, well and good, you can continue to the step one. And the step one will be, I am already in this folder web app demos, and it contains a few PowerShell scripts, Docker file, which is simply the one we saw, and then we have create local container registry. Okay, and this is PowerShell script. In this one, what we are going to do is we are going to execute few commands, right? These commands are yeah, .NET build. So just to test if your web app actually builds, then run, open new terminal to test, and then call. Okay, so this is just to test if your application is actually working. Then you publish with the release version, and then you build. Time to build the container app and image with the build tag, and tag it with the v1. Okay, and then in order to by default output from the command run in the container during the build and return to console, you need to add progress plane to see output from the commands running the build. If you already built the image, you will need to delete the image if for your cache new layers are built. So docker remove web app image v1, and docker builder prune force to force it to remove it. Anyway, okay, let's get started. I have already built my application, so I have already run these commands to test. So my app is well and good and working. I need to publish my app, and then okay, let's continue. Let's publish the app in the release folder. So if I just copy this and run it, okay, it has published in the it will publish in the web app folder bin, and it has created a release folder and it is in there. Okay, and now I want to take it image, so let's do the docker build. Now we are actually building the docker image, and wow, it is creating a perfect build from here, which is really interesting to see how they work. Nice. Okay. And then now I want to run. So I have already built the image from there. It used this one, this Docker file, and now next step is simply uh, run the image locally. So Docker run, allow access, because this is Docker is trying to someone is trying to connect to that image. Okay, and it's done. Okay, so now I just need to curl to this page. Let's see if the app is running in the Docker. And you see when I curl it output hello world version 1 and host name this blah blah blah. You see, so but the actual host name of my laptop is the laptop name, but here you see the host name is different, and that's how I know it is running from Docker. Of course, I know because I deployed it to Docker, of course. But another way to know is the host name is different, right? If you will test, if you will run this app locally, you will see the host name is different. Um, I can if I just run this part and check, host name is different. Anyways, so this part is done, and then um, we need to delete the app because yeah, we don't want to keep it running. So I will run all these commands all together and run. Okay, so you see web app image v1 image id this about a minute ago was created. So let's hold on to this, and because we wanted to create the image, and we will use this in the next demo. Thanks for watching. I hope you liked. This is just the beginning. I hope you liked it. Let's continue.
Now that we have a container image to be able to deploy or share it easily, we need a container registry. And in this course, we are going to focus on Azure Container Registry. Azure Container Registry is a managed Docker registry service based on the open source Docker registry, allowing you to build, store, and manage container images for container deployments. Azure Container Registry or ACR can be a core component of a CI/CD pipeline. It can be integrated into your source control systems and build container images when code is committed. Further, container orchestrators such as Kubernetes and serverless platforms like Azure Container Instances can be configured to pull images from those container registries. Further, you can use the Azure Container Registry task to streamline building, testing, pushing, and deploying images in Azure. ACR tasks offloads the build process of your application into Azure Container Registry and can be triggered to build a container image when your team commits code into source control. And then that image will be automatically pushed into Container Registry when the task is complete. The last concept of ACR that I want to introduce here is that there are several service tiers. Basic, standard, and premium are the current service tiers. As you move up in the service tier, you will gain more performance, image throughput, storage capacity, and also security and replication features. For more information on ACR service tiers, check out this link. I have it here because yeah, the SQs part is really interesting to know. Uh, Although they only have basic, standard, and premium service tiers, but the difference between them is really interesting. Let's continue. Azure Container Registry requires authentication for all operations, which is normal, right? Azure Container Registry supports two types of identities for logging in: Azure Active Directory identities including both user and service principals, and a service-specific ACR admin account. This is an administrative account which is disabled by default and is only needed in some scenarios. When building pipelines and automation container orchestrators, the tools and applications should use what's called headless authentication for their unattended logins into ACR. Headless authentication is only supported using Azure Active Directory identities. And we are going to focus on service principles in this module. You should not use ACR admin account for headless authentication by tools or containers orchestrators. From a user developer perspective standpoint, at the command line, you can use Azure ACR login or Docker login. Log into Azure Container Registry. You will be challenged for username and password, and then you will be able to log into ACR and perform operations. And for CI/CD pipeline, we will need service principal, which will be used for login for authentication purpose. Right? I think it's clear, right? If you want to do it via command line, then you can simply do like this. And if you do it via pipeline, you have to follow this way. Okay, I hope it's clear. Let's continue. The credential that you will use is your Azure Active Directory identity. When it comes to which operations you can perform, that's where role-based access control come into play, and we are going to look into those in more details in a moment for deeper dive into ACR, security, and the various supported authentication scenarios. Check out this link here. Um, Access to Azure Container Registry using an Azure Active Directory. Azure Active Directory identity is role-based, and identities can be assigned one of several predefined roles, and if needed, you can create custom roles. This is a listing of predefined role RBAC roles in Azure Container Registry. The roles there can be grouped into two use cases: role assigned to people and role assigned to tools. Azure Container Registry as an Azure resource and can administer or access its configuration using Azure tools. These roles also have access to content of the container registry itself, such as image stored in it. The role ACR push, ACR pull, and ACR delete are roles that you will want to assign to service principals when using headless authentication for tools or container orchestrators. These roles have access to the container registry data such as image, but do not have access to Azure Resource Manager. So they don't have access with Azure tools such as the Azure Portal, Azure CLI, and Azure PowerShell. Important, very important to focus here these things. The primary example of the right role for headless authentication for a container orchestrator or with Azure Container Instance is Azure's ACR pull. This role gives those services the right to pull an image but no other access to the container registry or the data in it. So if you just want to provide this role, which will only give related required permissions for ACR pull, same for push if you just give push, and the same for delete. But if you want to give other rights, then you have to give other roles like owner, contributor, or reader. Let's continue. To create an Azure Container Registry, we can use all of our normal deployment tools: Azure Portal, Azure PowerShell, Azure CLI. Let's walk through an Azure CLI example to see this in action. First, to make our code slightly better, More usable, I'm going to set an environment variable ACR name with tech of the day demos ACR. This will be our Azure Container Registry name, and this name needs to be globally unique inside of Azure because it becomes part of the fully qualified domain name that we will use to access this Azure Container Registry. To create an Azure Container Registry, use of command AZACR create, then you specify resource group name, and here we are going to go with the tech of the day demo RG, and then you specify the name, and then you specify SKU, which is standard here. Now to log into the container registry that we just deployed, we can use AZACR login and then specify the name parameter and then the ACR name itself. And again, I'm using the environment variable here. So this will log you in with your current Azure CLI credentials. In your current session, we will have administrative access to the container registry since you just created it. So now that we have a container image built on our local development workstation and a container registry deployed in Azure, it's time to push that container image onto container registry. And we going to use two different methods here. First using Docker tools, and then second using Azure ACR. Then next we need to get the login server for our Azure Container Registry. The login server is public DNS name specifying the network location of our Azure Container Registry. We can get this in the Azure portal by looking at the properties for our Azure Container Registry, but we can also retrieve it at the command line with the Azure AZACR. So, and specifying the container registry name, and then we can use the query parameter to extract the login server field. That value will be then stored in the environment variable ACR login server. The current value for the login server in our example is going to be a tag of the day demo acr.az.azure cr.io, and so that's a combination of our Azure Container Registry name, which is tag of the day demo acr, and the domain suffix azure cr.io, which is the domain suffix for all Azure Container Registries. Next, we need to add alias to our local container image using this login server and a new name and tag. This additional tag tells Docker where it needs to send the image when we execute a Docker push and create an alias. We can do that with Docker tag. And so let's walk through this command together. And so here we have Docker tag, and then for source image we have web app image v1. That's our local container image that we built earlier in this module. For the target image, for the alias, we are referencing ACR login server variable again, and then appending an image name and tag. And so in our example here, that's going to be tag of the day demo acr.azure.cr.io/web app image colon v1. Docker tag just tags the image with an alias. Now we need to push the image into ACR, and we do that with Docker push and then specify the image alias that we just created together. When this is executed, it will then upload or push the image into ACR, and it will be available to be pulled down by authenticated users or services. What we just covered so far is So far in this way, to build and push an image to Docker tools, we can build and push an image another way, which is ACR task. Using an ACR task to build our container image will read the Docker file into the current working directory and then zip up all the resources and code and then upload that into ACR to build our container image in Azure Container Registry. Once the build is finished, it will then be pushed into ACR for us to use. Let's look at how to do that in code. We can use the command add ACR build with the parameter image. This is what image will be named and tagged with the Azure Container Registry. And so here we have web API, web app image as colon v1, ACR task. Okay, and I choose to tag to identify that this was built inside of Azure Container Registry using a task. We then specify the name of the registry that we want to push the image to when the build is finished with the dash registry parameter, and then specify the ACR name. We see the space and then a dot, right? This is going to reference a local Docker file in that current working directory. So this part, it's really important, and please pay attention to this as well. um, so basically, to summarize, what we did is we created ACR name, we created ACR login server, and then we created a Docker tag for this with this web app image. We created ACR login server, and we did the Docker push, and then we build. If we want to do the same thing using Azure ACR task, then we can do the same thing using Azure ACR build, right? I hope it's clear. Let's continue. So creating an Azure Container Registry, time for demo. Let's create an Azure Container Registry together and push our newly created container image into Azure Container Registry. We will then also look at we can use ACR task to build an image inside of Azure and push it onto Container Registry. Let's get started. All right. So let's go to Visual Studio Code and get started.
Okay, okay, so I have already done the Azure login part, and I have already default subscription set. Now the thing is, let's create another Azure group, which is with the just create Azure group, create dash name with this name and location central US. Okay, and what I'm going to do is I'm going to change the central location here, because central US, my subscription is free tier and I'm not allowed to use this location. So I'll just change it and be right back. So okay, let's continue. I set the location to this one. Now I'll just execute this and let's see. Okay. um, okay, it is not understanding this thing. Anyways, I'll do like this. Um, okay, and now I can just copy paste it. And it will create a resource group for me. And now I have the resource group. Now I can log into, sorry, too fast. Now I need to create ACR name, which will be ACR this one, and it should be globally unique. And then I can create Azure ACR with this name. So ACR name, it is being used here. Basically, it is a PowerShell script which I should execute separately, but anyways, I'm not going to do that, so I'll just do like this. um okay, and then need to move this as well. Oh, and same for SKU. And now you have your command for doing the Azure ACR. So it will, what it is doing, it is creating ACR in this resource group, and the name is this one, and SKU is standard. Okay, and then what we will do is we will simply log into ACR to post containers, and this will use the current Azure CLI login context which we just did. So I'll use this and replace this name with this. Same here. It is taking some time. Let's wait for it. All right, so the Azure ACR command succeeded. Actually, it did not succeed in the beginning. It's thrown some error here. It said this already exists, so it should be unique globally, and it already existed. Azure 204 demo ACR. So for that, I added a tag of the day in it, and it was fine. It went fine, and now I have created a ACR with this name, and now I can log into it. So let's say Azure Azure login to this, and it will use my existing context. So I'm logging, the login is succeeded, and now what I'm doing is creating login server, and then I will use this login server uh, to display for the Docker tag part. Okay, let's continue. So I executed these 5 lines actually. So these 5 lines I executed, and then we see here, you see I created, so I tried from here. Reference is not valid, repository blah blah blah. Okay, this was a successful execution, and here you see the output. It tagged web image with this name, and then image is this, and then to list the images, you see these are the images we have. So one is Azure 204 demo ACR tag of the day dot Azure Azure CR.io repository. Then another one is with the v1 tag, and these are the um, image ID. Two images are there. So one image is there actually with the same image IDs. Okay, so now the thing is to push it to Docker. So to push it to ACR. So if you remember exactly what we have done till now, we have we built. If we go back from the step one, what we did, we created a local image, Docker image, and now what we are doing, we created ACR, and and then now we created we just listed if there is any image existing with this tag, and then now we want to push Docker push to this Azure ACR login server, and with this image tag, and then we can just list these images if they are successful there or not. So let's continue. So as I executed these 3 commands, Docker push, it has pushed all the web images there. Then I'm executing this list with this name, and then it has listed web app image result v1 uh, to show the tag on it, and which is v1, and now I'm back. So what we have done, now we have pushed the Docker push command, which will push the image to the ACR, and now I can Um, I can ACR build to build our image in Azure and then push it into ACR to use ACR build task, and you can also do the same thing with this part. So I'm not going to do this part here. Uh, that's it, because I just wanted to push create an ACR image, ACR, and then push an image to ACR. Okay, that's it, and let's continue.
Moving along in our Azure container journey, it's time now to learn how to run container-based application in Azure using Azure Container Instance. Azure Container Instance gives you a serverless platform as a service offering, enabling you to run containers in Azure without having to set up any virtual machine or other infrastructure service. It's most effectively used for simple applications, task automation, and also build jobs. When you need full container orchestrations, you should look towards Azure Kubernetes services. When you deploy containers in Azure Container Instance, you can access your applications over the internet via an automatically provisioned, fully qualified domain name, or optionally, containers deployed in ACI can be connected directly to an Azure virtual network for private secure communication. This can be combined with express routes or VPN gateway for access from other network outside of Azure. You can run both Windows or Linux containers in Azure Container Instance, but in this course we are going to focus on building running Linux containers. When defining your containers in ACI, you can specify an amount of CPU or memory needed to run your application. This default is 1 core and 1.5 GB of RAM. If your ACI deployed containers need persistent data for data files or even databases, containers can directly mount Azure files shares backed by Azure storage. Azure container instances also support scheduling of multi-group containers that share a host machine, local network storage, and lifecycle. This enables you to combine your main application container with other supporting containers such as logging, sidecars, to construct a more complex application scenarios. The final feature that I want to call out about ACI is that you can define a container restart policy. Container restart policy tells ACI what to do if an application running inside of the container stops, and your options are restart always, restart on failure, and restart never. Always will restart the container if the application running inside container stops for whatever reason, and this is a default option if you don't specify a restart policy when you deploy your container. The next option is on failure, which if the application running inside the container fails, then it will automatically restart by ACI. However, if the application exits gracefully, then the container will stop and not be restarted. And the final option is never, which when the application container stops, regardless of how it stopped, gracefully or ungracefully, the container will not be restarted. Now that we know that what Azure Container Instance is, let's see how we can deploy containers into ACI from various container registries. First, and the focus of this course is we can deploy containers from Azure Container Registries, and we will see how that works in the upcoming code samples and demos. Additionally, you can also deploy containers into ACI from any Docker compliant container registry, including Docker Hub. So there is no hard dependency on using Azure Container Registries. You can use any container registry. But as in the previous example, we already did that. So yeah, we will continue using Azure Container Registries. Now, when deploying containers, you can use both public or private container registries. When I say public, I mean registries that you can pull containers from anonymously without having to log in. A private container registry is one that requires authentication, like we did in the demo. First, we have to log into the ACR. In fact, the Azure Container Registry that we just deployed, right? And image into requires authentication by default. To authenticate to our Azure Container Registry, we need to tell Azure Container Instance two key elements when we deploy the network location of the login server for our container registry, which we learned how to find when we deployed our Azure Container Registry earlier in this module. And the second element that we need is authentication credentials, specifically a username and password that has the appropriate role-based access control rights to pull an image from our container registry. And in our upcoming code sample and demos, we will learn how to create a service principal and configure it with the correct role-based access control to do just that. I do want to reiterate that you can deploy containers into ACI from any container registry. In our course here, we are going to focus on running containers from Azure Container Registry in Azure Container Instances. So creating a service principal for ACI to pull from ACR. Let's walk through the code needed to create a service principal that will have access to pull images from our Azure Container Registry. We will then use this service principal in Azure Container Instance so that it can authenticate against our container registry and then pull the image for the container that we want to deploy. And so let's start off with setting some environment variables. First up, we will define ACR name, and that's the actual name of our container registry. And I'm using tech of the day and demo ACR, which is the name of the container registry, and we will that we deployed earlier. Update this to your container registry when needed. Now the next variable, we have the get actual resource ID of our container registry. Resource ID of container registry. And next we will define a variable for service principal name and then use AZ AD SP create for RBAC to create the service principal and then retrieve the password and store that in the variable SP password. And then going through the parameters for command, first up we have the name, which is going to be the name of our service principal. And then we have the scope, which is ACR registry ID, which we recovered here. Role is ACR pull, query, password, output to the TCV. So, and then we have saved it to SP password ID. All right. Then this will be required to pull our image from the container. Now we need to create SP app ID. Again, app ID will be used as username when authenticating to our Azure Container Registry. Now we are using environment variables here in our script for deployment. If needed, the service principal app ID and password can be stored in Azure Key Vault as secret for secure access and reuse. So we are just recovering them here like this, but we can also store them. So ACR login, and with the appropriate security laid out, uh, allowing Azure Container Instance to pull from Azure Container Registry, we can now tell Azure Container Instance how to deploy a container from Azure Container Registry using authentication. First, we will set the environment variable for our login server. This will be used to tell Azure Container Instance the network location of where our container images are stored, and also used in conjunction with the service principal ID and password to authenticate to our Azure Container Registry. Now to create a container in ACI, we use AZ container create. So basically what is happening now, we are creating a container inside the Azure Container Instance. So we will then specify the resource group, then name of the container, then the DNS name label, then port, image which we will get, which is from the ACR login server, this, and then registry login server, which is ACR login server, which we did here, and then registry username and SP app ID and password, which is we just did in the previous slide. So basically, we are telling to create Azure ACR to create a container. Okay. All
So
right.
what I did
Deploying
here
container.
is simply I'm
Um,
in my Visual
Deploying a
Studio Code
container
again,
using Azure Portal.
and what I'm
Um,
trying to do is I'm
I will skip
creating
this one
Azure Container.
because
I've already done these
that
steps
one
in the
will be
previous one,
simple
so I
then.
don't have to
And
do it
then
again.
let's
And
deploy
then
some
I'm just
container
creating
together in Azure Container
um,
Instance using
Azure
Azure
Container
CLI. Because yeah,
Azure
I don't
Container
want to do
create
it
in
with the
this
portal.
resource group
It
with
will be
this
simple.
name and this
Um,
DNS
so let's
with
go
this
ahead
image and on this port.
and continue.
Okay. And so what it did is um, the resource provider for Microsoft.container instance was not registered, which is generally the case for some of the subscriptions. So what it is doing is registering it for me, and registration succeeded. Now it is creating the container for me. So I'll pause for a while because it will take some time, and I will resume. All right, so it is created, and it shows me when I executed list, it shows me all these properties on this and a lot of information. Well, I cannot go through all this. And then let's continue. I will continue doing it, and so these are the further to execute. So as I shown you, I needed to get the password, I need to get the app ID, and then I will use all this information in the Azure Container Create. So I will execute um, this part before executing this, but I will just show you only this part because yeah, this is we have already discussed how to create a SP password, service principal app ID, eco. This will be printing all this, and then I'm creating getting the ACR registry ID, blah blah. So anyway, I will continue from here on, and I'll just show you after the pause. All right, I just created, I just executed all this bunch of code, and I put the URL like this, and then just printed it what it is. Then I created the change the name of ACR name, which was like this, and then I got the registry ID using this query and login server. Then I print the login server, then get the SP password, SP app ID, and then create the container. I'll continue doing it 1 second. It has an error. Uh, um, Argument registry username expected one argument. So 1 second, I will continue. Okay, now I'm running all this set of commands, which is initially getting the URL and then creating the ACR name, getting the ACR registry ID and login server, then password for service principal, along with creating the service principal, and then creating the container in the ACR, and then showing the container. All right. So and this is successful execution here. You see, and um, if I go to my resource group here, and if I refresh, if I go to container instance, and if I see here containers, I see tech of the day demo CLI container is created and running, and you see here the events which were started, built, and pulling. So you see the time and dates here, and this demo concludes here. So I hope you understood um, how to configure, how to create local container, and then how to push the container image to using Docker. Sorry, creating image using Docker, and then creating ACR container, Azure Container Registry, and then pushing the image to this registry, and then creating a container inside Azure Container Instance, and then finally, uh, so we are done till here. I can just container delete it, and then I can delete everything else. But I will keep it for now in my Azure portal for now to keep it for other things. But you can continue and delete your instances. So that's it for now, and I hope you understood.
All right, that's a wrap for this course, Microsoft Azure Developer Implement IaaS Solutions, where we focused on deploying virtual machines and containers. With this course, you should be prepared for the implementing IaaS solutions objective for your A204 HR204 exam. In this course, we covered how to provision virtual machines, how to configure VMs and remote access, create ARM templates, create container images for your solutions by using Docker, publish an image to Azure Container Registry, and then run those containers by using Azure Container Instances. We then learned how to publish images into Azure Container Registry, and then also how to run containers by using Azure Container Instances and deploying containers with Azure Portal and Azure CLI. So here is the end of this course, and I really hope you enjoyed listening to this and that we have laid the appropriate foundation for your Azure AZ 204 studies. We have covered a lot of ground so far together, discussing how to deploy virtual machines and containers in Azure. It's truly been a pleasure recording this course, and I thank you for your listening, and most importantly, learning with me. Thank you, and let's continue to the next part of this certification. Right, that's a wrap.
Hi, my name is
Please
Nitish Sharma,
write
and
down
welcome
your
back to
comments,
Microsoft Azure
questions, and
Developer.
suggestions in the comment box, and good luck with your exam. I hope you learned something, and because I tried to explain everything in my own way, maybe I wasn't clear enough, and maybe you have some feedback for me. So I would really appreciate your feedback. I put a lot of hard work in it, but maybe still it is not enough. I put more than 100 hours in preparing this course because it's really long and uh, it covers a lot of topics. Still, I might not have done a lot of demos maybe, but I would be creating a separate video for that, which will cover labs and some some other exam topics. So thank you for watching, and enjoy tech of the day, enjoy um, this course, and good luck for your exam. Hope it helped you a little bit, at least some degree. Thank you. Have a nice day or evening, whatever is suitable to you. Thank you. Bye. Have a nice day.